right, athletes, we're going to look at binomial distributions for discrete random variables. And I have a video on this, but you always got to up your game. So I just thought of something that could even help with our understanding a little further. So check this out. Let's jump into some problems here. All right, so first of all, let's make sure that you have a binomial distribution. Well, what the heck does that mean? Well, here's some things we look for, because again, this is all worthless unless you know when to use this. All right, so number one, we need a binomial distribution. So we need two outcomes. So let's read this problem so we could kind of walk through it. All right, and for those of you that are in my online class and in-person class, we're looking at section 6.2. For those of you not in my class, this is just the binomial distribution. This is the area that we're focusing on. All right, so check it out. You have a national survey reported that 34% of adults in a certain country have hypertension, right? They have high blood pressure. So a sample of 24 adults is studied. So what we're going to do is we're going to go and we're going to look at some probabilities. And if you see this first question here, we're trying to see, hey, what's the probability that exactly 4 of them have hypertension? All right, so here's what we're thinking about. We're going to go through and we're going to ask every single one of these 24 adults, do you have hypertension? And it's either going to be a yes or no, right? There's only 2 outcomes. So this is one of the criteria for this being a binomial distribution, right? You have 2 outputs, all right? There's also a fixed number of trials, right? We only have 24 adults here, right? So that's not changing. If I have hypertension, that's not going to impact the chances of you having hypertension. So every person is going to be, the probability of one person having hypertension is going to be independent of someone else having hypertension, right? They're not going to influence one another. And so these are the things that we look for when we have a binomial distribution, all right? And our fixed chance here is 34%. All right. So now that we have identified, and that's key, right? Knowing when to use this. All right, so now that we have identified that we have a binomial distribution, what we're going to look for is these words here. So are we going to be looking for the probability of maybe one thing happening, or are we calculating the probability of multiple things happening? So in this first problem, part A, notice it says, what's the probability that exactly 4 of them having hypertension? So here, we're only finding the probability of P of 4. So we're only looking at one thing right here of exactly 4. Right? What's the chance of exactly 4? We're not looking at for the probability of exactly 4 or 5. We're not looking at the probability of 1 or 2 or 3, right? So here we're just focused on one X value. And so our X value in this case, right, what usually goes in the parentheses here is 4. All right. So X in this case is 4. And look what it says here. The binomial random variable X, what does X represent? Well, X represents the number of adults with hypertension. So if I choose these 24 people, if I have these 24 people, maybe none of them have hypertension. Maybe 24 of them have hypertension, which is all of them. Maybe 19 of them. Maybe 13 of them. Each one of those numbers that I'm saying, that represents a different X value, right? And so that's why it's a random variable, because we don't know, it changes, right? So in this case, our X value is 4. So we're only looking at one number here. So make sure you write this down. Whenever you're looking for it, whenever it says exactly and then some number, we're going to use this program called Binomial PDF. And I'm going to show you how to do this. I'm going to walk you through your calculator here. So because we're finding the probability of exactly one X value, in this case, our X value is 4, we use Binomial PDF. So this is how you do it. Let's see, let me share my entire screen because I'm going to jump back and forth here. Let me hide this. All right, so check this out. We got a calculator here. We're going to go second, vars, and you're going to go all the way down to binomial. Notice you have 2 of them. You have binomial PDF and you have binomial CDF. So we're going with binomial PDF. All right. So binomial PDF, the first thing it's going to ask you for, your calculator is going to look a little different than this because your calculator is probably going to be a little fancier than mine because we be broke over here. So the first value it wants is the n value, right? How many people? Well, we said 24. All right, then we put comma uh in your calculator price is trials, right? And then it's going to want the p-value. Like, what's the probability that they give you? In this case, the national survey reported that 34% of adults have hypertension. So we're going to put 0.34. We're going to put that in as a decimal. If you don't put the decimal, you're going to get an error. Okay, so be careful of that. And then the x value that you're looking for. In this case, where our x value is 4. So we put parentheses. Again, your format's going to look a little different than mine, but same exact idea. Hit enter, boom, and you get 0.0349. So if we look over here, that's how they got 0.0349. All right. So this is the process when you're looking for only one x value. All right. So the next thing we're going to look at, what happens when you have more than one x value. So what am I talking about? Well, this next question exemplifies that. So what is the probability that more than 8 people have hypertension, right? So out of those 24, now we're looking at more than 8 of them. So notice more than 8, that could be 9 of them. That could be 10 of them. It could be 11, 12, all the way up to all 24, right? So now we have more than one x value, right? So luckily, we don't have to do every single one individually. There's a shortcut, okay? So now we're doing more than one x value. So the program we're going to be using is this guy called Binomial CDF, all right? So make sure in your calculator or in your notes, you write down, we use CDF when you have more than one x value. All right, so whenever we use binomial CDF, binom, I should say, binom CDF, the first thing it's going to want is the trials. Then it's going to want the probability again. And then it's still going to want this x value. What this x value is going to represent is the biggest x value. I'll put the biggest, and I'll tell you what I mean by that. Your largest x value. Because what this program is going to do, and so don't just use these programs, make sure you understand what the heck these programs are doing. This is going to calculate the probability of 0, right, of x equals 0, plus the probability of x equals 1, plus the probability of x equals 2. And it's going to go all the way up until you get to this value right here, whatever that number is. So if that was a 7, I would go all the way up to 7. All right, so whatever number is right here, that's what this program CDF is going to do, cumulative, because it's going to add up starting at 0 all the way up, all those probabilities. Well, Houston, we have a little problem here because look at what this question wants. It says, find the probability that more than 8. So let's think about this. When it says more than 8, let me choose a different color here. What they're saying is they want the probability of more than 8. More than 8. So what numbers am I thinking of when I say more than 8? Well, that's a probability of 9, right? Since it says more than 8, I can't start at 8. I got to start at 9 because it's more than, plus the probability of 10. And I'll have to go all the way up, dot, dot, dot. I would have to go all the way up to my last value, the number of trials, which is 24, right? So I'll have to do that. But look at the problem here. This program always starts at 0. These aren't starting at 0. So that's where my problem is, right? So how do we combat that? How do we solve this little issue here? So whenever they use the words more than 8 or the words at least, whatever, in this case, this will be at least 9 or at least whatever, those represent all these numbers from that number forward, and it's getting bigger and bigger and bigger. But because I want all the smaller probabilities, or this is what my program gives me, check out what we do. We're going to do 1 minus the complement of this. So we always use the complement, 1 minus the complement of the probability of more than 8. I'm just going to write using math notation here. So the probability of x greater than 8, right? That means the same thing as this. So what's the complement of more than 8? Well, the complement, the opposite of this, would be 1 minus the probability. Notice this starts at 9, 10, or 20, all the way up to 24. So the opposite of this would be 8 or fewer. 8 or fewer. And this is what you always want to get right here. Because my calculator, this program Binomial CDF, my calculator could do this, 8 or fewer, because what it's going to do is probability of 0 plus probability of 1 plus probability of 2, all the way to the probability of 8. All right. So again, I understand at first glance this is confusing. We're going to do another one to make sure we got the hang of it. All right. So again, whenever you have a more than situation, whenever you're getting the numbers to the right, the larger numbers, we're going to have to use this idea of complement. And so to find this probability, we use that program, binomial, binom, oops, that should be an N, binom CDF. And then the number of trials is 24. Our probability hasn't changed. It's still 34.34. And this time we tell the calculator, what number do you want to stop at? And we always stop right before this number. So if this is a 9, we stop at 8. And that's why we write 8 or fewer. All right, so this is where we stop. So this is what we plug into our calculator. All right, let me show you how to do that. So in our calculator, we do clear 1 minus, so to binom, we go second, vars, we scroll down to binomial CDF this time. Our N was 24, comma, our P we said is 0.34, and then comma, and then our X value, we want to go all the way up to 8. Those are the probabilities that we're not using, so we're getting rid of those, right? How do I know I'm getting rid of those? Because I have a 1 minus all these. I hit enter. So we end up with 0.432955. So when we look at our answer, 0.33 if we round. So if we round, yep, that's exactly what we got, 0.433. All right. So again, this is going to be a challenge. So one thing we need to do is let's practice something real fast. Let's pretend I'm going to make up a situation here that it said the probability that x is greater than 12, right? So what would be the complement of this? So first of all, let's write down what numbers this represents. So this is more than 12. So more than 12 would mean that I would need to start at 13 plus probably a 14 plus, and I just keep going all the way to the last one, which is 24, right? Plus probably of 24. And I'm saying 24 because that was our sample size. All right. So that's what this means. So again, so we practice. What's the opposite of this? Well, the opposite of more than 12 would be, so the complement, let me write this down. The complement of this would be the probability of 12 or less. Right? So you always want to write it like this. And the reason I write it like this is because this number is always going to be the number that we're going to use when we look at that binomial CDF. So this, the complement of this is probability of 12 or less, right? Because this represents starting at 0 plus a probability of 1, all the way up to dot, 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 all the way up to my last number, which is 12. So notice I got 12 or less, right? So these are the numbers that are the opposite, the complement of this right here, right? And because it's the complement, I now know in my calculator, I do 1 minus binom, and again, I just made this problem up, CDF, gotta be careful, binomial CDF, 24, because that's the trials. My probability has not changed, 0.34. And this time, my X value, I want to get rid of all the numbers up to 12. And why do I say I want to get rid of? Because it's a complement. It's 1 minus all these numbers. And this is what I would plug into the calculator. All right. So again, we're going to be practicing this idea much more in class. But for those of you that aren't in my class, go ahead and comment below. Or you probably can't comment right now. I'll save that for later. But this is what we're going to be working on. So what happens if you have a question like question C? All right. What is the probability that fewer than 4 have hypertension? Fewer than 4. Well, let's think about this. This is nice because probability that X is less than 4. So let's look at the numbers I'm looking at. So less than 4, I start at 0, plus a probability of 1, plus a probability of 2, plus a probability of 3. But look what it says, less than 4. So I don't include the 4 because it's saying strictly less than 4. So here I do not have to use the complement because I have all the numbers. When you use binomial, remember, when you use binom CDF, what this program does is it starts at 0. So because here I'm including 0 and all the other small numbers, I don't have to use a complement. So you only use a complement when the numbers you're looking for don't include 0 and the smaller numbers, right? So in this case, our trials, number of trials is still 24. And do this with me on your calculator. P is still what was it, 0.34. And this time you tell your calculator, what's the last number you want to include here? What number are you going up to, right? And that's the X value. So here, you're going all the way up to this 3. Right, so that's your last value. So this is what you plug in. That's what they plugged in right here. And this is what you get. All right. So again, whenever you're looking for numbers less, so when I say X is less than 4, another way of writing this is the probability of 3 or fewer. And the reason I like to use this format is because this number right here is going to represent your X value. Okay, so that's my little shortcut right there. So whenever it's already in this format, 3 or fewer or 5 and fewer, whenever it has or fewer, that means that this value right here is going to be your X value. So that's why I always like converting it to this right here, this format. All right, so that's how you're going to be using binomial CDF and binomial PDF. All right, just like my other video said. But again, I always want to take another shot at how I explain things because, sometimes we need to hear things different ways and a few times. The last thing I want to talk about is what happens when they ask us for the mean, to calculate the mean and the standard deviation of these values. Well, it's not too bad. So check it out. Here's our formula to calculate the mean. So N represents the number of trials, like how big your sample is. In this case, you could see that our sample is of 20 adults. And then P is going to represent, the chance of that thing happening that you're interested in. We call that a success, even though, having hypertension isn't necessarily a success. It's what we're looking for here. So that's why we call it success. So in this case, our P would be 0.30 because that's a chance that an adult would have having hypertension. So all you do is you just multiply 20 times 0.30. Boom. And that's how you get to 6. all right? But now to calculate the standard deviation, go ahead and write down this formula right here. If they want the variance, we'll write this, but typically we want the standard deviation, right? Because that's something we're going to feed into our calculator a little later. So what we do is we take the square root of n, which we said is 20, times p, which is a percent of success, which is 0.30, and 1 minus p, some books, they call that q. So if you're not in my class, maybe you've talked about q, which is just the complement, right, of this. So it's just 1 minus the 0.30, which is 0.70. So again, all you do is you plug it in just like this, 20 times 0.30 times 0.70, right? You take the square root of that, boom. If you want to see it on the calculator, second, this is my square root button, and I do 20 times 0.30 times 0.70. And I could just put 0.7 and 0.3. It doesn't matter, just in case you're wondering. If you ever get something like this, or to change it to a decimal, just go to math, and then right here, decimal. And they'll change that, hit enter. And there's 2.049. 2.049. All right. So that's how you calculate the standard deviation. All right, Matthew. So hopefully that was helpful. And just to make sure this isn't any different. Yeah, this is asking the same exact question. All right, guys. Hopefully you're having a wonderful day. I'll see you guys tomorrow in class. Peace out.